Okay. Yeah, we'll bring I'll carry the dry ice with us, and then, you know. Yes. Here we are today in beautiful Concord, Massachusetts, which is just west of the city of Boston. And we're here today because we're interested in the way in which climate change is having an impact on plant species around us. Our lab is largely interested in looking at plant evolution. By integrating these two fields, we found some very interesting patterns about the ways in which plant species in Concord have been impacted by climate change. We know that flowering times have moved to be 3 weeks earlier on average over the past 150 years. And this has greatly impacted the mix of species we find in Concord today.
This is glossy buckthorn. This is Rhamnus frangula or Frangula alnus. This is a very invasive shrub in Massachusetts. It's just about anywhere, especially a little bit wetter woods. It tends to get into wetlands quite frequently. It's kind of a sneaky invader. A lot of people don't know what it looks like. It's not showy like purple loosestrife or some of the other ones that are very brightly colored or obvious. So this is kind of a understory plant that comes in and starts to shade out other species.
This is the pink lady slipper orchid. Its lower petal has a shape that looks like a slipper. This is a member of a group, the orchids, that is in striking decline here in Concord. So what our data suggests is that the orchids as a lineage are not favorably responding to climate change, and they're ones that we should pay special attention to in terms of conservation management priorities, in terms of their possible continued decline in the threat of future climate change. Concord has a rich history that traces back to Henry David Thoreau. Thoreau spent decades surveying the landscape and in particular looking at flowering time in Concord starting during the 1850s. Temperatures have increased over the last 150 years about 5 to 6 degrees Fahrenheit. So there's been a dramatic shift for plants to be flowering earlier today than they did during the time of Thoreau 150 years ago.
Okay, so we have 2 new species for our list here, both wetland Aquifoliaceae.
We estimate that upwards of 30% or so of the species that Thoreau saw we can no longer find in the Concord area. It's not to say that they're extinct globally. In nearly all cases they're not. But in this regional area where climate change seems to have had a dramatic impact, there are many, many species that have been lost, which Thoreau saw and you can no longer see today. I think it's a really critical point.
So how many, okay, Thoreau got about 550 species?
I think that's about right. And Eden maybe collected about 450.
Okay.
And then Richard Premack maybe, and Abe probably got around 400-ish or so. So 400. In terms of overlapping species, there were 400-ish that we're looking at across the entire... What we've been trying to do is to understand the connection between ability or inability to respond to temperature by adjusting flowering time response and, extinction, at least locally on the landscape. And in particular, trying to understand if there's any underlying evolutionary pattern to the ways in which species are responding or not responding to climate change. So, what we're trying to do is to document all of the species on the Concord landscapes. And one of the best ways to do that is to make a long-term museum collection. So this will actually be archived at the Harvard University Herbarium so that people can access it, 100 plus years from now. Because we're actually trying to study genetic responses to climate change and also think about building the kinds of evolutionary trees that we've used to understand patterns of climate change in Concord, Massachusetts. We'll take a little bit of tissue to sample their both DNA and RNA in the laboratory once we return to Harvard University. What we can do then with these sorts of data and observations is make better and more thoughtful predictions about the kinds of changes that we may actually expect to see in the near future as a result of increased climate change. So in a sense, what we're doing is trying to understand the past to make better predictions about the very near future in terms of conservation and management kinds of strategies.